Good morning. Again, we will discuss the another consequences of Lorentz equations, that is variation of mass with velocity. As we know, mass is also variable in Lorentz equations. It is not absolute or constant. So variation of mass with velocity. As we know, you have already learned this formula. M is equal to m naught upon 1 minus v square upon c square under root. So this is basically relativistic mass. So in this equation, m is called relativistic mass, m naught is rest mass of the body, and 1 minus v square upon c square under root is the Lorentz factor or relativity factor. Now, to prove this formula, we will consider two inertial frame of references, as we have already using these frames. Let two frames f and f dash is moving with velocity v with respect to f frame along x-axis. But in this case, in the variation of mass, we will consider two particles, or two balls, b1 and b2. b1 red ball, b2 is green ball. And this ball is moving with velocity u along positive x-axis side, and this ball is moving with velocity minus u, or the velocity u along towards the ball b1. Means both balls are approaching to each other with same velocity u and minus u. Minus means direction is negative, otherwise magnitudes are same, u and minus u. So this is happening with respect to f dash frame. So these are the values. Basically, these values are with respect to f dash frame and not with respect to f frame. With respect to f frame, these values are different. So I will discuss in next slide. So this is the diagram, that is velocity u and minus u with respect to f dash frame. So that let mass of two elastic balls b1 and b2 in frame f dash is m, that is masses are also same. In f dash frame, masses are same, velocities are same in f dash frame. But what is happening, what is the observation in f frame, it is not clear here. I will clear in the next slide. So I have written these lines only with respect to f dash frame. Means the person which is moving with velocity v, he is saying that the balls have same masses and velocities are also same, but they are approaching towards each other. This is the observation of the observer in f dash frame. Next, by applying the law of conservation of linear momentum, as we know, the momentum of first body plus momentum of second body is equal to momentum of total body. So we know that momentum of first body mu plus momentum of second body m into minus u, that is minus mu, is equal to 0. 0 means when these two balls strike with each other, then they will coalesce. Coalesce means they will combine in a single ball. So the velocity of two bodies after collision is v, but with respect to f dash frame, that is 0, because relative velocity of particle v with respect to the frame which is also moving with velocity v, net velocity is 0, and hence this equation is formed. Momentum of first particle plus momentum of second particle is equal to momentum of total both particles, that is m1 plus m2, that is m plus m into 0. So 0. Thus the coalesced body must be at rest in frame f dash. Now what is happening in f frame, in first frame? Let u1 and u2 be the velocities of two elastic balls, same balls, in frame f. So with respect to frame f, these balls are moving with velocities u1 and u2. It is not true in f frame. So in f frame, the balls are moving with velocities u1 and u2, and masses are also not equal. Let us see. The velocities are same. So according to Lorentz velocity transformation equations, which I have proved in the previous lecture. U1 is equal to U plus V upon 1 plus U into V upon C square. That is, it is the x component of velocities. So in that case, here Ux, here is also Ux. But by putting applying this equation for two balls, so this is the case. U1 is equal to U plus V upon 1 plus U into V upon C square. Similarly, U2 minus U, that is velocity of the ball, second ball in F dash frame, plus V upon 1 minus V into U upon C square. So after collision, when they are colliding with each other, then they coalesced. So the coalesced body means combined body moves with the velocity of frame F dash, because velocity of the frame is also V, and after collision the velocity of two balls which coalesce to each other is also moving with velocity V. Thus V is observed with velocity in frame F. So let M1 and M2 be the masses of balls B1 and B2 in frame F. As I have already said that masses of these two balls is not same in F frame, because these are same in F dash frame, but in F frame they are not same. So the masses are M1 and M2. Really, it is happened that masses will change. So by applying the law of conservation of linear momentum, again the momentum of first particle M1 U1 plus momentum of second particle M1 plus M2 into U2 is equal to momentum of coalesced body, that is total M1 plus M2 total mass of two balls, and velocity is V. So this is with respect to F frame F. So using the equation first and second in third, this is third equation and this is second, putting in first equation, we will get this equation. And on solving, by taking LCM and rearranging this equation from left to right, ultimately we will get M1 by M2 is equal to 1 plus U into V upon C square over 1 minus U into V upon C square. So from equation 1, that is 1 minus U1 square upon C square, 1 minus this term I have taken only to prove the equation of mass. So putting value of U1 here, you can see 1 minus value U1 is here and upon C square, and we will get on solving this equation. So similarly 1 minus U2 square upon C square is this. So these equations we can solve by taking these terms. So dividing equation 6th and 5th, this one 6th and 5th, on dividing we will get 1 minus U2 square upon C square or 1 minus U1 square upon C square. That is this left hand side. Again on right hand side we will get this answer. Then from equation 4th and 7th we will get M1 by M2 is equal to this equation. And on rearranging, M1 is this into this is equal to M2 into this. Got it. So from this equation number 8, it is clear that the left hand side and right hand side both are independent of each other, and we know it is true when each equal to a constant, because by symmetry in two equations we can consider it as a constant, another constant. So that is first part, left side is equal to right hand side is equal to constant. That constant is m0. Let it be assumed. m0 is the rest mass of the body. Then, thus, m1 is equal to m0 upon 1 minus u1 square upon c square under root, and m2 is equal to m0 upon 1 minus u2 square upon c square under root. From above equations, these equations, it can be concluded that if m0 be the rest mass of the body, then its mass m, when it moves at speed v, will appear as m is equal to m0 upon 1 minus v square upon c square. That is, we have taken u1 and u2 is equal to v. So both equations can be written by a single equation. So this is called relativistic formula for variation of mass with velocity. This is our article. If we substitute, this is a special case, V is equal to C, then put V is equal to C. Then we will get 1 minus V square upon C square means 1. So 1 minus 1 0, and ultimately m naught upon 0 under root, that is infinity. So the mass become infinity. Thus no material particle, because we know that no any particle which have mass infinity. That is, no material particle can have the velocity equal or greater than velocity of light. So from here, this is very important result, because no any material particle possess infinite mass, or we can say that no any particle can have velocity equal to or greater than velocity of light. So thank you very much.